Okay, so the nth term test for divergence, remember it's for divergence, says that if we take the limit as n approaches infinity of a sub n, and if that doesn't equal 0, then the series diverges. So basically, if we don't approach 0, the series goes somewhere else, okay? So it diverges. If what we don't know is what happens if the series approaches 0. We don't know if the sum of the series is going to be convergent or divergent. So this is really only a test for divergence. So here's a couple examples. So this is our first shortcut test, the nth term test, okay? So we're saying the sum as n equals 0 to infinity of 2 to the n. So 2 to the n is a sub n. It's basically what the equation to give us the terms of our series. Remember, so if we had s sub n, we are going to say that's equal to a sub 0 because we're starting with 0. So 2 to the 0 plus a sub 1, which is 2 to the 1, plus a sub 2, which is 2 to the 2, plus this is going to go on to infinity and beyond. Okay, so we can test to see without having to write the equation for the nth term of the sequence of the series. Then what we're going to do is use the nth term test. We're going to try by taking the limit as n goes to infinity of the nth term of the series. So the nth term of the series would be a sub n. So this would be 2 to the n. So I'm going to plug in infinity. And so 2 to the n does not equal, 2 to the infinity does not equal 0, okay, because that's all we're testing is if it equals 0 or not. And since it does not equal 0, according to our situation here, the series diverges. So we would say the series diverges by the nth term test, which I usually just write NTT. Okay, and remember the series is representative of the sum of n terms n to infinity of 2 to the n. So if you want to write that to remind yourself that that means the series, then go for it. All right, so the next one, we have the sum as n from terms n equals 1 to infinity of n factorial over 2 times n factorial plus 1. Okay, remember this business right here next to the summation is my a sub n. This is the equation for all the terms in my series. So without having to figure out that nasty s sub n equation, I can just be like, the limit as n approaches infinity of the nth term, which is n factorial over 2 times n factorial plus 1. And what I end up with is the numerator is increasing. The numerator and the denominator are increasing basically at the same rate by a factor of n factorial. So what's going to happen is we're going to end up with infinity factorial over 2 times infinity factorial. The 1 is, it's so small it doesn't matter. Okay, so the infinity factorials cancel. Remember, this is really each DC because they're increasing at the same rate. So I end up with 1/2, which does not equal 0. So the series, and I'll just name the series, the sum from terms n equals 1 to infinity of n factorial over 2n factorial plus 1 is diverges by the nth term test. Okay, last one. So we have the sum of from terms 1 to infinity of 1 over n. So I am going to go ahead and just use my nth term test. Remember, 1 over n gives me the value of each term. So I have the limit as n approaches infinity of our a sub n, which is 1 over n. And I get 1 over infinity, which gives me 0. So the series, so what we have is inconclusive. The series can diverge or converge. We don't know. So we move on to another test that we don't know how to do yet. Okay, so it's inconclusive by nth term test. So we're just going to chill for now, and then later we'll figure out how to do this. Okay, all right. So those are your examples of the nth term test.